So let's get started. My name is Manuvir Das. I work on the Windows Azure team. This is the lap around the Windows Azure platform. Thank you all for attending today. I know you've all been to the keynote this morning. You've heard Ray and Bob talk about the platform. I'm the developer. So my talk is not going to have a lot of nice pictures. It's going to be a very nuts and bolts talk, a lot of text about what's really in this platform. And I think if I do my job well today, you're going to get in 1 hour sort of the book on the Windows Azure platform. Everything you should know about this platform to sort of really get going with it. So I know the title of the talk is a lap around, but I'm actually going to treat this 1 hour as a bit of a marathon, like the New York City Marathon. So the way we're going to do this is, we're at the bridge, the marathon's going to start off, everyone's got a lot of energy. You get that initial kick, you sprint really hard. So we're first going to do this sprint through the platform, and we're going to really breeze through and look at everything that's in there, do an inventory in a few minutes just to make sure we're all on the same page as to what we're actually talking about and what's in this platform. And then, you do that initial sprint and you get a little tired, so we'll pause. We'll catch our breath and we'll look around and see the scenery, the Statue of Liberty or what have you. And so that's when we look back at the platform in context, and I'll set it up for you. What's the philosophy, the how, and the why, and where we're going with this thing. And then we'll settle down for really the long race around the city, and that's the lap around. And I'll give you this sort of guided tour through all the different parts of the platform. And then at the end, you come to the end of the marathon, and you get that second wind, and you do another little kick towards the end. So we'll do that. We'll breeze through the commercial launch itself and what that really means, and what you get with that. And then there's a prize for getting through the marathon and finishing it. So I was actually here a year ago introducing Windows Azure for the first time at PDC. And I made a mistake in that talk because I forgot to do the Q&A session at the end. And I got yelled at for that. But the funny thing is, instead of benching me, they actually sent me back this year and said, this year you better make sure you do the Q&A. So we'll do the Q&A at the end. That's the prize. There's microphones in various places. So even if I say I'm done and you can leave, please don't do that. The microphones are here, and feel free to ask questions. Okay. So as I said, I'm the developer, so I don't have any nice pictures. So this is my picture of the Windows Azure platform on one slide. It's all text. There's really three parts to it. There's Windows Azure, which is what we think of as the operating system for the cloud. This is the thing that hosts your applications and provides you lots of storage. There's SQL Azure, which is the database in the cloud. And then finally, there's the App Fabric, which Bob also talked about this morning, newly branded, which is a set of higher level services that application writers on this platform would find useful. So those are really the three components that make up the Windows Azure platform. And then going with that, as part of the platform, Microsoft, of course, is a strong developer tools company. So we have a set of developer tools that are well integrated in the platform, things like Visual Studio. And then, as you heard this morning, we have a project codenamed Dallas, which is about discovery in this platform. So there's an ecosystem around this platform as well. So that's really the components of the platform on one slide. The commercial launch itself, just to put that in context, what we're talking about here, today we're at PDC. We have a CTP of this platform as we've had for the last year. The difference is that we now have a full feature set that goes with the commercial launch. It is available. So if you were already on our CTP, or if you're attending PDC, you get tokens into the CTP if you were not in it already. So you can start to experiment with these features, play with them. There's still time to provide feedback. We've gained a lot of feedback from all of you and others who are not here in the last year, and we'd love to get more feedback. So that's where we're at right now. In January, right after the winter break, we actually launched the commercial platform where you can put in your credit card and sign up and see your usage, your VM hours and things like that. And then February is really when the paid usage begins. So the way to think about January and February is it's the same platform in January and February that you signed up for, but on the 1st of February, you get a credit for whatever consumption you had in January, right? Okay, So a quick tour through, this is still the sprint. So one slide on each aspect of the platform. So Windows Azure, as I said, is the operating system, if you will, for the cloud. And so as you might imagine from an operating system, there's three parts to this. The first part that we call compute is it's an environment for actually hosting your applications, right? So we've got a bunch of servers in different data centers on which we have virtual machines, and these applications are running on these virtual machines. So that's the first part of that. But Windows Azure is more than just a way to take a VM and run an application on it, because what's unique about the cloud is that your application is not just running on one machine or one VM, right? It's running on a whole bunch of machines, and that brings its own challenges. And so Windows Azure really provides a model for lights out service management. And the way to think about this is, in Windows Azure, you don't just provide your code, you actually put down what we call a service model, which is a description of your entire service. And that allows us to actually deploy, manage, and monitor the service for you. So that's the second part of it. And then finally, just like you have a disk on a single server, Windows Azure provides with it a storage system at massive scale, right? That is geo-distributed, so you can store all your data in a durable way so that it never goes away. Okay, so that's what Windows Azure is about. I'm going to sprinkle, I have these blue slides sprinkled throughout the talk. Blue is, of course, for Azure. So I'll give you these pointers to some of the talks that you can go to get more information in this. So for Windows Azure itself, we have an overview talk for that part of the platform that is at 1:30 this afternoon in this room. As it turns out, the speaker for that talk is also me. Yes. So if I get confused between the two talks, I'm sure you'll understand. But I promise you something different after lunch, and if nothing else, I'll change my shirt, okay? So we'll pretend it's somebody different, and I'll tell you all about Windows Azure, and I'll get into Windows Azure itself in a lot more detail in that talk. The second part of the platform is SQL Azure, which is our database in the cloud. So the way to think about this is everything you know and love from SQL Server, except that it's provided to you now as a service. It's an endpoint at a URL that you can hit, but you can do your joins and all those kinds of things. But because it's a service, certain things like high availability, how do I replicate my stuff so that data doesn't get lost, et cetera, is all done for you by the service. Where to put your database, et cetera, it's all done by the service. And really, it's an extension of the SQL Server data platform into the cloud. It's actually running SQL Server on every one of its servers, so there's a lot of goodness that comes out of there. Okay? And of course, we have a talk for that as well, which is also in this room at 3 o'clock. I'm not doing that talk. Okay, so that's the good news. Okay, yes, you can cheer for that. Okay, by the time I'm done with this one, you might be cheering even harder that I'm not doing that one. Okay, but note that they're all in the same room, so you can pretty much stay here all day between, I think, this hall and the one next door. You should be covered pretty well. Okay, so that talk's at 3 o'clock. The third part of the platform that I talked about is what we branded as the App Fabric. Some of you who've played with the platform in the last year might recognize this as .NET Services. There's really two components to it that we're going to talk about today. One is the service bus, which allows applications in the cloud to connect to each other securely and also connect to things that are running on premises. And then there's the access control service, which is a way of offloading all the work of authentication and authorization somewhere else so that the application doesn't actually have to do it. As you heard from Bob this morning, there's actually a lot more that is going into this aspect of the platform, the App Fabric, things like distributed cache, et cetera. But these are the two services that have been out there in the CTP for the last year that we're going to focus on talking about right now. Okay, and then the final aspect that I'm going to talk about of the platform today is this new project codenamed Dallas. The way to think about this is information services. So whether it's data, unstructured data, structured data sets, real-time web services, this is a facility by which you can get access to these data sets and consume them, or you can publish your own data sets. So it's really a system for brokerage and discovery of these things. It is available, it will be available as a CTP as part of the commercial launch, and it will come online in full mode later on. So I'm going to talk a little bit about that as well. So this is really the sprint. So we're done. We raced across the bridge, and we're going to pause a little bit and talk a little bit about why we built the platform this way. But I think the bottom line thing I want to say about this platform before you even get going is there's different pieces here, right? There's some compute, there's some storage, there's some database, access control. Clearly, there is some rationale to why we picked this set of things. And the reason we picked this set of things was that we really wanted this platform to be a one-stop shop that has all the right functionality so you can build a complete application from the ground up. And that's what we've tried to put in here. And I thought that instead of me standing up here and telling you that, hey, this platform is actually complete in some sense and you can do something with it, I might as well ask one of our customers to do that. So we've been working with a company called Ticket Direct out of New Zealand, and they were kind enough to put together a video that I'm going to play for you, so we'll hear from them in their own words.
Hi, I'm Chris All, Director at Intergen, a Microsoft Gold Partner in sunny New Zealand.
And I'm Matthew Davey, Managing Director at Ticket Direct, one of Australia and New Zealand's leading ticketing providers. We're working with the Intergen team to build the world's fastest ticketing system on the Windows Azure platform. Ticketing is a very hard problem to solve because you have such huge spikes in load. Most of the time, you're selling a few hundred tickets an hour, and then a big event goes on sale, and you need to sell 100,000 tickets in an hour. We are really excited about the Windows Azure platform because it will finally enable us to cost-effectively deal with these big spikes in load.
We're going to buy tickets for the Highlanders and Crusaders rugby match. This match is a local derby match and is hugely popular when it goes on sale each year. When we know we're going to get a big spike in demand, we can turn on hundreds or even thousands of Azure compute instances. Historically, it's been very hard for ticketing providers to handle load because it is very intermittent. You don't want to pay for 1,000 servers sitting around doing nothing most of the time, do you, Matt?
No way. Windows Azure lets us adjust our scale dynamically and only pay for what we use.
So Ticket Direct are long-time users of SQL Server and have a significant investment in SQL Server stored procedures for ensuring the golden rule of ticketing. And what's that, Matt?
One bum per seat.
One bum per seat, exactly. To handle peak loads, the ticketing data for a popular event may be partitioned across up to 100 SQL Azure databases. As a development shop, we can use all of our favorite tool sets with Azure. The Ticket Direct site is 100% ASP.NET MVC, with a bit of Silverlight sexiness sprinkled and a bunch of WCF services. We found it really easy to port the existing SQL Server database into SQL Azure, and we even have a legacy VB6 application connecting up to SQL Azure as well.
We have a soft lock on our ticket in the database, and it's being held for us to complete our purchase. There are Azure Worker instances that will clean up unsold tickets periodically. We're going to choose to pick up our ticket. When we choose this option, the tickets will be printed at the venue and kept for us to collect.
In order to print the ticket, we resolve the appropriate printer in the service bus registry and then send the print request as a message down to the venue via the service bus.
Our venues have all sorts of firewalls and other devices that control their internet connections. By using the service bus, we can reliably reach all of our ticket printers no matter where they are in the world.
We're going to pay with our MasterCard. I hope the credit card processing company scales as well as we do, Matt.
You're right there, buddy.
So the power of Azure is that we get the same great experience, whether we've got a couple of hundred concurrent users or 100,000 users, all battling it out for the best seats. And because Azure lets us add and remove capacity when we need it, we're only ever paying for what we use. Our tickets have now been printed remotely down at the venue offices via the service bus.
Now we're able to head off to the stadium to watch the Otago Highlanders, my home team, thrash the Canterbury Crusaders.
Good stuff, Matt. So we use the breadth of the Windows Azure platform to deliver the solution for Ticket Direct, and that really is the power of that platform. We were able to reuse much of our existing expertise and our existing code, including being able to run our SQL databases in the cloud.
Right from the first time we saw Azure, we knew it would be a great fit for Ticket Direct. We're really pleased that we bet on the Windows Azure platform early. It is a major strategic move for our business.
All right, and I think actually we have them with us here at PDC. They're somewhere in the audience. So there they are. Raise your hands, guys. So if you have more questions, you can, yeah, thank you. You can find them and grill them in some detail. Now, as I mentioned, I am just a developer. So I have a different way of looking at their story, which is a lot more basic, which is here's their architecture, right? And so I thought I would take a second to talk about how they've used the Windows Azure platform. So they've used the compute to actually run the application in the cloud with web roles and worker roles. There's stuff running in the venues that's on premises. They're using Service Bus to connect to that. They're using Windows Azure Storage to store actually a lot of the data that their application in the cloud is computing. And finally, they're using SQL Azure quite heavily, just the way that they use the SQL Server in their existing code. So that's a quick demonstration of what you can do with this platform. Okay, so now I'm going to take a few minutes to step back and talk about the how and why behind this platform, right? And the way I want to start doing that is by walking you through what were the things we had in mind as our design principles, right, when we architected this platform and started building it. And there's really 4 things that I want to stress. The first is this is a platform for business-critical applications, right? That is what we are here to do at Microsoft. So the first thing that implies is rock-solid fundamentals. Fundamentals that you'd always expect and specific ones for the cloud. The second point I want to stress is that from the beginning, the design of this platform has been, it's not just hardware for rent. It's really a way to take advantage of the cloud to let you lower the TCO, the total cost of operations, of actually running applications or a business in the cloud. The third principle is, it is a one-stop shop. We've put a lot of functionality in, and we've used all of the facilities we have at our disposal at Microsoft to really build an environment for you that is a complete environment, that is a holistic environment where lots of things come together in a seamless way so that 2 + 2 becomes 5. But at the same time, this goes hand in hand with interoperability. So this is a complete comprehensive platform that provides you all the functionality you might want to build an application. At the same time, this is not a monolithic system. This is not a system where all of this is required. You can mix and match and use the things you want to use from Windows Azure along with things from elsewhere, whether they're on-premises or in other clouds. Okay, so let's start with the fundamentals. The reason I've broken this slide up into 2 buckets is, I think the first bucket is kind of self-evident for any platform, any software system. Clearly, security is a key thing that we focused on from the beginning. Especially because this is running on servers in the cloud that are not necessarily sitting in your own office building. Performance and reliability are just basics for every kind of platform that you would build, as you can imagine. So there's not much more to say about that. High availability is a key facet of the cloud here, because when you're taking a dependency, a business dependency in a platform that is running the application, it just has to be there all the time, right? So when we started off on this project, the mental model that we had as a development team was, it's like electricity coming into your house, right? That was the design goal. If this platform doesn't meet that goal, then we've not done our job, right? It has to be the case that you have this expectation that whenever you need it to be there, it's there, right? And furthermore, the platform should let you build your own services easily in such a way that whenever your customer needs your service to just be there, it's there, right? And then the other 2 aspects that I called out separately, because they're unique things, unique opportunities that come with the cloud. The first is scale out. The cloud is really a model where instead of buying single servers that scale you up, right, you buy commodity hardware and you scale out. And that's the way, as the folks from Ticket Direct were telling us, you can scale up and down depending on whether you've got a popular game or not, right? And then finally, multi-tenancy is a key thing we've built into the cloud. And the reason I listed it here as a fundamental is because in our design, what we've done is, whether it's the compute or the database, from the beginning, we've put in primitives for multi-tenancy that are sort of future-proof, and that will allow us to provide many different models of multi-tenancy as we go along. And then the customers, the developers can choose what is the right model of multi-tenancy for your particular application. Okay. The second aspect is to lower the total cost of operations for our developer customers. And there's 3 ways that we have done this in the platform. The first part that I really want to stress is that this is not just some infrastructure or hardware we've provided. We have really worked to raise the level of abstraction at which the developer interacts with the platform. So you're not managing servers or VMs. You're managing a complete service, and the platform is here to help you do that. Similarly, on the database side, you're not managing a particular database, you're managing your data, and there's a service provided that handles the database. And the way that this particular facet reduces the cost is, number one, it lowers the cost of development, because there's a lot of crafty, cruddy code that you would have to write, for instance, to monitor a server or what have you, that you don't have to write anymore. And it also reduces the cost of operations, because since we've raised that level of abstraction, there's a set of things day to day that you don't have to deal with. The second aspect of this cloud that lowers the TCO is that the resources are shared, right? As I said, we have multi-tenancy built into this platform. And what that means is, number one, as a new service coming into the cloud, you don't have to pre-provision and purchase your own dedicated resources like servers and routers and load balancers, because you're just sharing from the pool that already exists. And then even the cost of operations day to day, as Chris was saying, as the load goes up and down, you're only paying for what you use, your share. And because the platform is a common place that is hosting so many different things, you get that benefit, right? And then finally, an aspect that Bob talked about in his keynote this morning that you'll see come back again and again. Microsoft as a company has, over the years, built a pretty strong technology stack, right, that all of you are familiar with and have used to build applications. And there's a lot of expertise that's been built in. And one of the design goals of this platform is to allow you to take that expertise as is and bring it to the cloud. And this will really reduce the cost of development, because you don't have to go learn a new language or learn a new paradigm to build applications for the cloud. And it also reduces the cost of maintenance, because there's a lot of familiarity built in, right, as with the particular code that's being written. And this theme will come back again and again at this PDC. And this is a point I want to make, that in the year that we've had the CTP out, we've received a lot of feedback, and we've worked pretty hard on the platform based on all the feedback we've received. And this was a pretty strong point of feedback, and it really matches the way we were going with the platform. The next principle is better together. 2 + 2 is 5. So really, this is a one-stop shop for all the functionality, but it goes beyond that. Our services, the platform is located across the globe in data centers in different places. And all these different services, whether it's the service bus or the database or compute, they're all co-located in all these places. So you can deploy some compute and database in the same place, and you get all the benefits of latency, et cetera, that you would expect by being together. The platform has built in, as a first-class concept, the idea of one project across the platform. I'll show you that in a second. You create one project, and that includes some database from the database service and some compute from Windows Azure, and you manage all of that together in one place. And at the same time, as a customer, when you get your usage and your bill, again, you get one experience in one place, as you might expect. And then finally, there's functionality that is shared across all these different components of the platform. So for instance, there's a marketplace that we launched yesterday based on Microsoft Pinpoint, where you can list your applications so that others can find them, and you can find other people's applications. That's just shared functionality built in the platform. Dallas, that we talked about this morning, is another piece of shared functionality that's in there. Okay, so I thought I would do a little demo for you of how all this fits together. So the first part of it is I want to show you the commercial platform and how you sign up in one place. Now, the commercial platform is not live yet. It'll be live in January. So I'm just going to show you a couple of screenshots here. This is from the trials we were doing in October that I was doing with one of my accounts. So you can see this is the Microsoft Online portal that already exists, which now has a section for Windows Azure. And I see some smiles, because I noticed some people have probably noticed that logo for .NET Services, right? Because as I said, this is from the trials back in October. And when the commercial platform comes online in January, clearly that thing will say the Windows Azure Platform App Fabric, right? So you go, you select that, you put in your credit card information, and then you choose a project name. This is your project that goes across the whole platform. So I just chose that project name, Manuvir Test. And then once you've consumed the platform a little bit, you you get your bill, and this is what basically that statement looks like. And you can see it's collated all the information from the different aspects of the platform, and you get your bill in one place. So this part is not live, so I had to show it to you via screenshots. But of course, the developer portals where you actually manipulate the projects are live and have been live for a while. So that I can actually show you live. So here's my laptop, and it's connected to the internet. And I'm going to go to the Windows Azure developer portal. I'm going to sign in over there. Right? So I'm going to sign in. Okay, so now I'm in the Windows Azure portal. And you can see this is my list of projects, and I have this project called Manuvir Test. And in this project, I have some storage and some compute. So I have a compute app that I've deployed, which is called PDC demo, right? And I'm sure some of you in the audience, this looks familiar because you've visited the developer portal. So I have this application running, and notice that if you look at the bottom of the screen, this application is deployed in a geolocation called South Central US, right? And we have multiple geolocations. Now, I'm sitting here in my compute, and there's a panel on the left for all parts of the platform. So if I click on SQL Azure, it will take me to the SQL Azure part of my project called Manuvir Test, right? And did I click? And in the SQL Azure part of my project, I actually have a database created, which is also called PDC demo. It should pop up momentarily. There we go. There we go. Okay, and so I have a database here called PDC demo. And if you'll notice from the top of the screen, this is also deployed in South Central US, right? So you get that aspect of the geolocation, right? Right. Okay, so that was a little demonstration of how the platform all sort of comes together. The final principle that I want to stress was interoperability. As I said, this is not a monolithic platform. It comprises these different services that you can mix and match. You can use any subset of these services. Also, we have APIs on all these things, so you can build your own tooling. For instance, the service management has APIs on it, so you can build your own service management tools. I think the other aspect of interoperability that I really want to stress is that the platform is language agnostic. So, for instance, if you think about the compute, hosting your applications on Windows Azure, this is not a ASP.NET, .NET framework only platform. Certainly, that's a platform we believe in very strongly, and it's well supported. But really, we support any language framework that is supported by Windows Server. So you can run Java applications. You can actually install Tomcat and host your own web server for Java applications. You can run PHP, what have you, right? And we see that as a good thing for the platform. The services themselves are language agnostic. They all have open web APIs like REST APIs, so you can have client libraries in any languages. We've actually worked with some partners to publish an SDK that is a PHP SDK, for instance, and a Java SDK for some of our services. And then finally, the platform is connected. So this is not an isolated application environment where if you host an application here, this is where you can be. Applications can connect to other things on premises or on other clouds, as I said. And in fact, we've built services like Service Bus that encourage that and make it really easy to connect to applications in other places. And just to give you a sneak preview of that, we actually have a session this afternoon at 3 o'clock in the hall next door on how you can build Java applications with this platform. And then immediately after that, in the same hall, we have another talk that actually talks about PHP and some other technologies also on top of that can be built on top of the platform. Okay, so that was a little bit on sort of the philosophy and where we're trying to go and what the design principles for this platform are. The next thing I'm going to do is do a lap around and get into some of these components for you. So we'll start with Windows Azure. There's three parts to it. The first part is application hosting. So because your application is running not just in one VM, but on a set of servers, we introduced this concept of a service model, which is, you can think of it in pictorial terms, where you basically describe, what is this service that I have? Its architecture. So in this particular case, you're saying I have some web role that is taking in web requests behind a load balancer, and I have maybe a backend role and a middle tier. We struck a balance with the service model where you tell the platform enough so it can do a good job of deploying, but not too much that it becomes cumbersome or constraining. So for instance, in this picture, the parts that you specify in the service model are, what is the set of roles that I have, and those endpoints. The part that you do not have to specify is those yellow internal edges about who's talking to who and how, because that's something that can change pretty frequently, right? One of the aspects of application hosting that this platform provides built in is service healing. So what that means is, for instance, if one of those instances of a role running on a VM stops functioning, maybe the disk drive went bad on that particular machine, the platform detects that automatically. It spins up another one in its place. It comes up on a new IP address, and then there's a notification mechanism so that all of the service gets notified that, this role instance went bad, we brought up another one, here's where it is, so you can reconnect. Okay, so the theme that we're going to stress throughout this PDC when we talk about the platform is this aspect of familiarity and how you can continue to do things the way that you've always done. So it's time for another demo to show you how you do this with application hosting in Windows Azure. So I'm going to switch back to my laptop here, and I'm going to show you a little sample application that I've got. So this is a little sample app that I wrote over the weekend, actually. I've brought it up in Visual Studio. I use Visual Studio to build it. It's a Windows Azure Compute app, but I'm just going to run it locally on my desktop. As some of you know, our SDK comes with a complete simulation environment that lets you run the same application you would have run in the cloud on your desktop with multiple instances and all of that. This application is a simple ASP.NET app that is basically talking to a SQL database, and it's basically just creating. It lets you create some entries and insert, delete, etc. It's just a little string in every row. And I'm actually running it against an instance of SQL Express that is on my laptop. And the points I want you to note is just I'm using some standard commands to insert, delete, etc. Right? Okay, so I'm going to launch this from Visual Studio. I do Control F5, which does the build, and then it's going to launch that simulation environment on my desktop. And now it's starting it up, and it's going to bring this thing up in the browser momentarily. Here we go. So this is my application. It's talking to my local SQL Express instance. Now, because it's running in my simulation environment, I can start up this UI for this simulation environment called the Development Fabric. And I can look at this. This is a console window that is showing me all of the logging output from this service as it's running, this role instance. And this output is basically from the platform saying that the application has been started, right? And then I can go here and I can create a couple of entries. So, etc. Okay, so I have this application up and running now. Okay, so the first point I want to make is that this application, actually, this code is standard code, right, that I would have written using SQL, etc. Now, let's say I'm running this thing in the cloud and I want to do some debugging, right? I want to do some logging to find out what's happening in my application. So in Windows Azure, we've built in a complete logging and diagnostics facility that we just released, which is basically it's running with your code. It captures all the logs. It pushes it into your Windows Azure storage account, so it's all durable. It doesn't get lost. It aggregates from all the different instances you might have into one place. But we also wanted to make it the case that the way you interact with this logging system is no different than the way you do logging today. So if I go back to my application here, you will notice that I've put in an event here which basically says invoke this method called item inserted whenever an item is inserted. And I've got the implementation of that method in this code behind over here. And I didn't actually want to make mistakes typing this in the demo, so I have it already, but I just commented it out. So now I'm going to bring it back. And this is just standard code, right, that you'd all recognize for tracing. So I'm just going to write that out. I'm going to save this. And now I'm going to build this thing again. I'm going to run it again, this time with this tracing statement in there, and we'll see what happens. So here we go. Notice that those two entries that I had created earlier are actually over there now. Okay, and that thing started. So now I'm going to try to add some entries again. Let me try hello. Okay, so I've got this entry called hello. And now if you notice in the console here in the development fabric, I made a logging call, which was automatically recognized as a call into our logging system and our provider. So it went through the whole logging diagnostics pipeline, and it showed up here on this console. If this application was running in the cloud, this would also have been pushed to Windows Azure Storage. Okay, so let's play around with this a little more. PDC MDs. Notice that you might have noticed I didn't actually do a write line. I just did a write, so I didn't put a new line in, so that this whole thing can show up in one line from okay, and there we go. Hello from Windows Azure. So that's the Windows Azure logging system into the cloud and all of that aggregated, but you write exactly the same code as you wrote before. Okay. All right. The second aspect of the platform is the service management, this lights out service management. What we've done this year is we had a developer portal where you could go and manually interact with your service and deploy a new service, scale it up, down, etc. That is all now exposed through a REST service management API, which we have provided, and we've also provided tools in the SDK. So you can script against this. You can do this programmatically. If you combine that with the logging and diagnostic system that I just was talking about, you can actually build a whole feedback loop and monitor your service in real time and make decisions about scaling up, scaling down, etc. We've also introduced a new model for service upgrade now, which we call in-place rolling upgrade, where basically your service is running, you bring some new code or configuration in, and as the service is running, we've basically broken your service instances into chunks, and we roll that upgrade through a little bit at a time, and you get to specify what chunks you want that upgrade to happen in. And then finally, the storage part of Windows Azure, blobs, tables, and queues are things that we put out in the CTP last year. This year, we're introducing the concept of drives. This is also storage in the cloud, replicated, etc. But the difference is that from your application in the VM, you get to use the standard file system API. So you're talking to NTFS, but what's happening is that all of those reads and writes are not just going to your local disk, but also transparently going out to the replicated system in the cloud. So it's durable, and you can connect to it from other machines, etc. The storage system is really designed for the cloud from day one, from massive scale. That was a key design decision that you'll hear more about. It's designed for durability, so you never lose your data. And there's APIs, so you can access it from anywhere. And there's a session on this on Wednesday that's a deep dive into blobs and this new facility, Windows Azure Drives. In terms of where we're going with the Windows Azure part of the platform, these are the things that the team back in Redmond is actually working on as we speak right now, because we're done with all the functionality that's in the commercial launch itself. So we're really looking to get this out as the next wave of facilities in the coming month and year, and that time frame. So on the first front, which is the programming model, today it is the case that when your application runs in a VM, it runs in full trust, so you can run Java, C, etc. But it runs with user privileges, and we are working to enable administrative privileges, which unlocks the possibility of running more legacy applications that install things, for instance, into C program files. So that's the first facility. And then hand in hand with that goes a facility that Bob was talking about in his keynote this morning also, which is today's model in Windows Azure is you deploy an application. So on the VM, we have pre-installed and configured the operating system, and then the application is brought in and started. It can run installers that are in user mode. With this facility, what basically, the way to think about this logically is that you get to basically specify the operating system that you want to begin with. You get to set up the operating system by configuring it, by installing certain things you want to install in there that touch the registry, et cetera. And then when we're done with all of that, you get to snapshot that and say, that's the image that represents my role. And then what Windows Azure will do is, instead of deploying just your app into a VM, it'll deploy that whole image into as many places as you want. The point I want to stress really strongly at this juncture is, this is still all under the auspices of the Windows Azure service model. So you still describe your service architecture. I've got a web role, I've got a backend role, all of that. It's just that the delivery mechanism is different, that instead of just taking your ASP.NET code or what have you, you can produce the whole VM image, which unlocks the full power really of the VM for you. So you still get all the benefits of service healing and all those kind of things that are built into the platform. On the storage side, as part of the commercial launch, we have built in geo-replication into the system already, which is how we make sure that when we replicate all of your data, it's not just replicated within a data center, but it's actually replicated across data centers. That's something we are doing at the commercial launch already. What's coming next with storage is actually allowing you to choose where you want that secondary data center to be, because that might be a choice you want to make. And then there's more innovation coming on the tables. And finally, on the service management side, we are going to be providing remote terminal server access into these VMs, so you can get onto the box. I would just mention, though, for the 3 people who are in this room, and don't tell your friends, I would just mention that we have a facility called the service bus, right, already on the platform. So it is actually the case today that even though we don't give you a facility from Windows Azure to hit that VM from the outside, your VM can connect up to Service Bus, right? And so you can actually get onto a VM by using Service Bus as the mediation point, but don't tell anyone that, right? And I know you won't, okay? So the common theme to this whole slide really is, it's all about familiarity, about doing more and more to make sure that the applications you love and build with all the technology you're familiar with can translate into the cloud. Okay, the next aspect is SQL Azure, which is really the database service in the cloud, right? So this is a relational database. This is SQL Server that you know and love. You connect to it with TDS, you write T-SQL to talk to this database. It's a symmetrical experience. As the folks at Ticket Direct told us, they took existing VB6 code that they had that talked to SQL Server on premise and just used it as is. But the difference is it's provided as a service, which means that it's highly scaled out on our hardware. The high availability that you would normally worry about building for yourself is already in there. So I want to stress that this is not hosted database, right? This is not a facility that says, hey, we'll put SQL Server on a few boxes for you, and there you go. This is a service. You just hit an endpoint. So high availability is provided for you. You don't have to worry about, how do I make sure that if this instance of SQL Server goes bad, I'll be able to get my data from there. I want to switch over because I'm doing an upgrade or some maintenance. All of that is taken care of by the service. The actual provisioning of the databases is also provided by the service. And then a key point to make here is that as compared to the hosted model, this is a multi-tenant environment, right? So in a hosted model, you're sitting in a world where you say, okay, I've got a VM, I've got a database running in the VM, I'm paying for that VM, right? But here, you're only paying for what you're using shared within this whole database service, right? So that's a key aspect of having the database as a service. So time for another demo about familiarity. So what I'm going to do now is, I'm going to go back to the same application I had just shown you, running on Windows Azure, which was hitting my local SQL Express instance. And let's see if I can, walk the walk, having talked the talk, and see if I can seamlessly move this over to SQL Azure, right, without changing anything. So the mantra we've had from day one of SQL Azure, the design goal that we've had from the beginning is, what we should be able to say is, change your connection string, and you're done, right? So if I go back to Visual Studio now, what I've done here, you'll notice with the code, is I have a connection string that I'm using to connect to my local SQL Express. And there's a configuration value called PDC demo connection string that I've got sitting in my web.config. Again, this is just standard web.config. And here's my connection string, and you'll notice that it's the connection string for my local SQL Express, right? And what I'm going to do is I'm going to go back to the portal, the developer portal for SQL Azure. I have this database called PDC demo, which is in the same schema as the database I had locally on my SQL Express. And I'm going to select connection strings, which is going to give me the connection string I should use to hit my SQL Azure database, right? And I'm going to copy this off to the clipboard, and then I'm going to paste it in there and run my application again. Now, it struck me last night when I was working on this demo that there's going to be skeptics in the audience who are, I'm going to run this demo, and then they're going to say, oh, you must have done some, sleight of hand in the background, and this isn't really a real demo. So I figured, okay, here's what I'm going to do. I'm going to go back here to my connection string, which is for SQL Express, right? I'm going to remove it. I'm not going to put the new one in. Let's save that and build this and run this, right? And this should fail, right? So let's see what happens. Okay, so this doesn't fail because the connection string is empty, which is what you would have expected. All right? Okay. I think I've got too many things open here, so close that. All right. Okay, so all right. So now I have that connection string, which I should have copied to the clipboard. I'll copy it again. Okay. I'm go back to my web.config, and now I'm going to paste that in here. Now, notice that the connection string actually has a placeholder for my password, so I got to put that in, which is actually PDC09 demo. Now, it struck me, the other thing that struck me last night when I was working on this demo is everybody's going to see my password, right? Which means actually in the next 2 minutes before I get to running this thing again, one of you in the audience could take this information and hit my database in the cloud and make some changes. But then it struck me further that that's a good thing because I can use that to make this point. This really is a database in the cloud, right? You could actually do that. That's the power of SQL Azure, right? I mean, this is shared development. So we have this little race condition going, right? So let's see who wins. Let's see who can type faster, okay? So I put the new connection string in with my password, okay? Control F5, come on, quickly, okay. Did I save it? Yes, I saved it, Control F5, okay. All right, okay. Startup. Okay. Launching the browser. Sorry? Yeah, I set the firewall rules. And actually, that's a very good point because, I was talking about somebody else could do that to my database. But one of the neat things about SQL Azure is it allows you to set firewall rules also from the developer portal. For the purpose of this demo, I actually set a very liberal firewall rule. So you could actually blow up my demo. But in practice, in reality, that's another facility you would use to protect yourself, right? Okay, so now I'm hitting my SQL Azure database, which is empty, right? So this is not the one I had locally. I'm going to start up this development fabric again. Because remember, I still have the logging on, so I want to see how that works. Okay, and this is all started. So now I'll go back here and let me add some entries. So insert hello, PDC, attendees. This is now going to SQL Azure and being read back from SQL Azure. The reason it's 16 is because I was playing around with this last night. So hello PDC attendee showed up here from my logging. And this time I'm going to say from SQL Azure. Okay. All right, so hello from SQL Azure. All right, all I did was I changed my connection string. That's it. I didn't touch anything else. Okay, so that's the database as a service. One of the new facilities that we are bringing online with the database is data sync. Again, this is an extension of the SQL Server platform into the cloud. So what you should expect and what you will continue to see is all the goodness that we've built into the SQL Azure platform will keep flowing into, with the SQL Server platform, will keep flowing into SQL Azure as we go. So data sync is really it's a set of tools and runtime, if you will, that lets you use SQL Azure as sort of this backend where you have your data and you can synchronize, right? So what can you do with this? For instance, you can take your on-premise apps and you're essentially just changing the provider, if you will, and talking to SQL Azure. You can build these cache mode clients, right, and you sync back and forth. And really, I said there's no pictures in my talk, but I guess I stole one. So that's a little picture of showing where that is. And we do have a talk on this also on Thursday that'll give you all of the details on how you use the sync framework from SQL Azure. Okay, the third part is the app fabric, which really comprises the service bus and the access control service. So the service bus is this way of connecting different applications. And I think the main power of the service bus, if you will, is imagine if you have two entities, A and B, and they cannot really connect to each other because of either organizational restrictions like firewall, et cetera, right? And so maybe A is your application in the cloud, B is your backend on-premise, and there's no way for A to connect to B because it'll be blocked by the firewall. And what the service bus says is, I'm the mediator, both of you connect to me, and then effectively you're connected to each other through me. And that's what the service bus is doing. So if you think in that model, the patterns for using this fall out immediately, right? The first pattern is eventing so that you can tell devices about certain things that are going on. And clearly, we saw an example with the printing of the tickets for Ticket Direct. The other example is secure remoting, where you can take an on-premise application and connect it up to something in the cloud, which is a common paradigm that we expect people to follow in the cloud, because there's many scenarios where you will want to have part of your application in the cloud, but there's other parts of your application that you very much want to keep on-premise in a different environment, right? And then finally, tunneling is just straight app-to-app communication, right? So that's the mental model you should have for service bus. It's really a way of making two things connected together. And again, it's provided as a service. So all the innovation for supporting different language paradigms, et cetera, for talking to each other, innovations in the efficiency, et cetera, of this communication, all get built right into the service. We have a session that drills down into this as well, which is SVC 18 on Thursday. Okay, the other service that is in the app fabric that I want to talk about is access control. So the way to think about the access control service is this. Imagine you're building an application on the Windows Azure platform, and this is an application where you have some users, right? And depending on who that person is who's signing into your service, you want to let them do a different set of things. Maybe the person's an administrator who gets to change the database, or is a vanilla user who gets to view some information. So in your service, what you're going to have to do is authenticate these people and then do some kind of claims management for, okay, is this person allowed to do X, Y, or Z? And this is code that everybody is going to have to write for their applications. It's code that is going to change and evolve over time as the industry evolves in terms of the different standards and protocols and frameworks for doing authentication and claims, right? So what we've done is we've built this service once called the access control service, which does all of this for you, and you just outsource this job to the access control service. So the way to think about it is somebody comes into your service, they get redirected to access control. You have set up the access control service to say who your users are and what set of capabilities they have. The access control service will validate them, whether they're using Live ID or Open ID or what have you, and generate a token which says, okay, this is what the person is allowed to do. And then they actually hit your service with the token. It's all seamless and built in. And you don't have to do all this authentication, et cetera. You just take that token and let them do what the token says they can do, right? And so as you might expect, it supports a lot of these protocols and standards like RAP and SWT, which is this token format. It's integrated with Active Directory. And the key point about this slide is not just the list of the things it supports now, but this is the service where we'll continue to innovate and keep supporting all the new protocols for you as they come along, right? And we have a drill down on this as well, SVC 19, which is on Wednesday, okay? Finally, Dallas, the information service. The way to think about this is a place where you can discover, list, and broker content. whether it's blobs, like maybe some videos that you're sharing, public data sets, structured information, real-time web services. And there's an ecosystem really of content providers. So if you need some content for an application you're building, you just go find that content here and you sign up for that content, whatever the contract is with the other person, to use that. It's also a place that you can put your content in, right? And there's facilities built into Dallas that let you process and analyze the data, do analytics, if you will, so you don't have to build that. I think the most important point on this whole slide that I want you to take away is that part about empowering. Right? The way I think about this is, with Dallas, what happens is, if you want to be in the big pond with the big fish, you don't have to be a big fish now. You can be a small fish and survive with the big fish in the big pond, because you're going to get the same data sets and access to all that stuff without being a really big shop and having to go do all of that, right? So that's really the power of this thing. And we do have a session on that, which is actually right here at 4:30 this afternoon. So this is what I was telling you in the beginning, right? Just camp out here all day and you'll be in good shape, okay? So the last part of it is the commercial launch. As I mentioned, so as you remember, I told you in the beginning, this is the marathon, so we're going to breeze through the last part, right? So the timeline, as I mentioned, this is all a staged thing getting us to February. There's a billing model built in with an SLA. There's a whole talk on that I'll refer to in a second. We have phone support, as you might expect. We have a marketplace where you can discover things. The platform is available across the globe. The billing model, as you can expect, you pay for VMs and databases. There is actually a talk specifically on that. I'll come back to the previous slide, which is SVC 54. That'll give you all the details about how you pay for this thing. The platform is available in many countries in different languages, and there's data centers in the US and Europe and Asia that are available at the commercial launch, and you can choose which one you want to be on, right? So to put a bow on this whole thing, there's 3 parts to the Windows Azure platform: Windows Azure, SQL Azure, and the App Fabric. And it's really here to host your business critical applications. We think the platform is ready. As I said, we're heading towards the commercial launch in just a matter of a few weeks, and you can start working with the platform now and see what it's got. So that's all I have, but remember, there is time for Q&A, so you can walk up to one of the microphones and ask me any question that's on your mind. And before you do that, thank you. Yes, please, go ahead.
What you're supporting SQL Server-wise. Is it user-defined functions, table and scalar functions, and 4XML?
Oh, okay. So I cannot answer those questions specifically, but I think if you come to this, the SQL Azure drill down at 3 o'clock, you'll get specific answers to those questions. Okay, sure.
Where does velocity come into play?
Yes, sorry, I can't see. The question is, when does velocity come into play? Yes, actually, that work is very much underway, and you should expect that to happen fairly soon. And actually, the velocity implementation is compatible with Windows Azure, and it's running on Windows Azure today. So it's just a matter of logistics of getting that out there. So it'll happen fairly soon. Yes.
You mentioned multi-tenancy, and it really wasn't clear. You're laying groundwork now, but multi-tenancy isn't there. You've got a model that's there now, and more will be coming. Can you elaborate a little bit?
Yes, that's a good question, and the question is about multi-tenancy, and it's my fault for not being clear on that. We've built the platform from multi-tenancy from day one, so it is there. Okay, so for instance, when your application runs on a VM, it is multi-tenant because on that server there are other VMs hosting other people's applications. You're also multi-tenant within the cluster because on the big cluster of which the server is one part, there are other applications running. So that multi-tenancy is already there. On the database side, the same server that is hosting your SQL Azure database is hosting other SQL Azure databases as well, right? What I really meant to say was, this is one granularity of multi-tenancy. And what we've laid the groundwork for is that depending on your requirements, you may want different levels of multi-tenancy. So you may have a business requirement that I really don't want to be on a cluster with other people, a private cloud, if you will, right? And my point was that the platform today has this level of multi-tenancy, which is you get a VM in a shared environment, you get a database in a shared environment, but we intentionally picked a low enough level of granularity that from there you can always build up and provide less fine-grained models of multi-tenancy, if you will.
Can I have multi-tenancy within the application?
Well, that's for you to do as an application writer, right? So for instance, you can take a VM and host a web server, and then you can host, website, many different websites on that web server, for instance. Mm-hmm. Yes, and you could certainly do that.
Thank you.
All right, did that.
Good.
Hi, how you going? Are there any plans for additional data centers, say like in the Middle East or Australia?
I'm sorry, could you repeat the
Are
question?
there any plans for additional data centers, say like in the Middle East or Australia?
Oh yeah, that's a good question. So there are certainly plans for additional data centers. And if you go to the drill down talk by Diane O'Brien, I think it's SVC 54 on the business plans, there'll be a lot more information on our plans for additional data centers. I can't speak to Australia specifically, but there are definitely plans for data centers coming along, and we're already working on some of those.
Okay. Cheers, thank you.
Sure.
How do you maintain the service level? Over here.
Okay,
Over here.
yeah.
Hi. How do you maintain service levels in your environment? For example, if you're on a machine with other applications and one application starts taking up too much memory or too much CPU, how do you ensure that your own application doesn't suffer and start slowing down?
Okay, that's a great question. So this is why we designed the level of multi-tenancy that we put in with quite some care in the beginning. So when we say that you have your virtual machines within a server, right? Mm-hmm. Number one, you have your own VM that is not being shared with anyone else. Number two, the VM model is tied to the physical hardware with certain guarantees. So every VM is running on its own core that is not shared with anyone else. It's running on its own memory that is not shared with anyone else. It's running its own disk that is not shared with anyone else, right? And so when you look at our VM specification and it says, the small size VM gets you 1 core and 2 gigabytes of memory and so much disk, that's truly belonging to that application, right? And we've done a lot of work with our virtualization technology to maintain this performance isolation between VMs.
Okay, so it's not just a logical separation, but physically
yes,
you have...
Yes,
okay.
yes. It's based on the physics of the server as well. Now you can choose different sizes of VMs. So you can choose a larger size VM where you get more than 1 core, but if you're the VM that's 1 core, it's yours. And even if you chose a VM with more cores, they're all
okay. Thanks.
yours. Yeah, sure.
Is there a database physical file size limit that can be uploaded and used within SQL Azure?
Yes, so there's different options for signing up for SQL Azure that have sizes tied into them. There's a 1 gigabyte and 10 gigabyte. But I think the key point to note about SQL Azure is that even with those numbers that exist today, from an application, you can create as many SQL Azure databases as you want, right? So for instance, the Ticket Direct guys, what they did was they create one SQL Azure database for every venue, right? And so they literally have, hundreds of SQL Azure databases from one account, right? So there's...
So if there's one database in usage, if it went past 10 gigs, it would, pretty much...
Yeah, so, and I think we have the drill down at 3 o'clock on SQL Azure, right? And that would be a great question to ask at that drill down.
Okay, thank you very much.
Sure.
Is there capability of programmatically bringing up and down VMs? For instance, if we had you need once a week or something of doing a multi-processor process or something, but we only needed it for 4 hours at that time, and we just wanted to have something in some other service, bring up the VM, do what it needed to do, and then bring it back down again.
Yes, absolutely. And that's why we've published the Service Management API, which lets you do exactly that. You can build a tool to do that, to bring things up and down. And also the billing model for the VMs is by the hour, right? So you can do that. You can bring up 100 instances programmatically, run them for 4 hours, take them down programmatically, and you can keep doing that. Absolutely, yes.
Does that also work for allowing the VM to bring itself up and down?
Sure, there are APIs actually in the runtime within the VM that let you start up and recycle, stop, etc.
Okay.
Right? I would just say note that this is a rental model, right? Mm-hmm. So once you spin up the VM, you're paying for the VM by the hour, right? Whether you're actually running something in there or not.
Right.
Yes.
Understand. Thank you.
Sure.
The SQLN, is it shared or is it dedicated for one use?
Your question is about SQL Azure, right?
Yes.
It is multi-tenant. So it is the case that a single server, right, is hosting multiple databases. Your databases and others' databases, yes.
So therefore, how do you maintain the privacy, security, so I don't...
Yes.
If there's a problem with the SQL server, I may hop
Yes.
into someone else's database and pull out that data.
Yes, and so the SQL Azure team has done actually a lot of work as security is the key pillar that we started with. There is a drill down talk at 3 o'clock. I think that's a great question to ask there. But the SQL Azure team, I can tell you, has done a lot of work specifically to address those concerns, right? And this is true across the platform with multi-tenancy, right? Yeah.
Are you familiar with the Cloud Computing Security Initiative, CSA?
No, I'm personally not familiar with that.
Thank you.
Sure.
Will you say a few words about backup and disaster recovery?
Yes. So as I mentioned, the storage system is at commercial launch is replicated both. Firstly, all the data is replicated 3 times just inherently in the storage system, right? So that gives you a level of disaster protection. And then the data is also at commercial launch replicated across data centers. So that makes sure that even if there's a disaster that takes out a data center, the data is actually protected.
In short, you're guaranteeing if it commits, it commits.
Okay, the precise way you phrase that is kind of interesting because I would say it this way, that once you've got data stored in the system, the data is there even if a data center goes down, right? But the way you put it was, once it commits, and that leads me to a semantic thought of, okay, when exactly do you get the commit back? Because things are moving, right? Data is being published to different data centers, and obviously it takes time for data to move, right? So I'm not here to make any statement that, within 1 second of doing a write, you're fine in another data center. So this is, I don't want to put any timings on it like that I think your question implied. Just think of it this way, that all the data is also replicated into another data center, right? So if this one goes down, the other one is available, okay?
Could you elaborate a little bit on the block storage? You said NTFS now is persistently stored. NTFS APIs can be used to access persistent storage.
Yes.
Can you talk about that and also how that, if it's layered on blob storage, are you able to use both to access the same data?
Yes, it's layered on the base substrate of our storage system, which is really a replicated data store. And the blobs are just one abstraction of that store. And now this concept of a drive is a different abstraction on the same store. So the first answer to the question is, the way to think about this is, from your storage account, just like you create blobs and tables and queues, you can create a concept of a drive which is named. In the VM, we have built in a driver that basically provides some APIs that from your application code, you can mount one of these named drives sitting in the cloud. Once you've mounted it, any regular operations you're doing via NTFS are going into that drive as well, okay? It is true that this is actually one of the nice facilities that because it's all built in the same system, as you pointed out, you can actually view this many different ways. You can snapshot it and then connect to it from a different server. You can snapshot it as a blob and then view it as a blob. And you can certainly do those things, yes.
But it's not, it doesn't support multi-user semantics. So if I have multiple roles, like can I or can I not access?
It supports a single writer. So you you hook up one VM to it that's doing writes into it.
Okay.
But it also has a read-only mode that is slightly different, yes.
And the readers can share the same volume?
Yes, there is, as I said, there's a read-only mode that allows multiple readers to get to it. Yeah, and there's actually a very nice deep dive. Brad Calder, who's the architect of our storage system, is going to do a talk precisely on how the whole drive system is set up.
Thanks.
Sure. Is that this evening at 4:30?
No, that's not. That is, I'll have to look for it, but it's called the Windows Azure Storage Blobs and Drives Deep Dive. Yeah.
So my question was about the logging thing you talked about.
Yes.
You said that you can use standard Windows diagnostic API. Is it resilient in the face of a crash? Let's say you've got multiple VMs writing to the same logs. Are they guaranteed to be, in order? What if one of the writers crashes? Will that disrupt the log? Because that's a problem on Windows that you guys fixed with the logging infrastructure. So
yeah. Okay, so the point you mentioned about the multiple writers and the different VMs writing to it, yes, that is all accounted for by the logging system. It really comprises, there's a logging agent that runs per VM that is resilient to a lot of things. You know, it subscribes to ETW, et cetera. It's got a circular buffer for how it records things. It's got its own health model. It restarts when it needs to. And then the writing into the cloud, again, it's writing into our storage system, the same vanilla storage system, right, which is already resilient to multiple writers and all that kind of stuff. Okay. It's all built in.
So
yeah.
If I was to access the log, you mentioned something about replication to multiple data centers. So
yes.
Will all of them be eventually consistent? Will all of them have the same data at some point?
Yes, yes. But remember that the replication to the other data center is a transparent thing that is there for disaster scenarios, right? You're seeing your primary replica. All your APIs, when you talk to storage system, you're getting your data from the primary replica. The secondary is not active, if you will. It's there for disaster recovery.
All right. So, and I can query my logs saying we're ready. I can accept the data. Is there like a...
The logs are available as they get written,
okay,
just from your storage system. And there's a lot of configuration built into the logging system to say how often you want stuff pushed into the cloud and what level granularity of information you want.
Thank you so much.
Okay, sure. I think I'm out of time for any more questions, so thank you.